Really? Well, we are continuing to work on Chapter 8, Section 1. This is the last day, people, we're working on this. So please, pay attention. We've got a lot of factoring to do right now. The very first thing that I would like you to do in problem number 11 is realize that I'm going to rewrite this as a negative a squared plus a 9. So I'm taking the negative a squared and I'm moving it up front. I'm taking the positive and I'm moving it in the back. First step. Now, the reason why I'm doing this is for a particular reason. I'm going to factor out a negative out of the a squared, and I'm going to factor out a negative out of a positive 9. Now, that kind of sounds kind of crazy, but I'm going to do it. If I take away a negative out of an a squared, I'm left with an a squared. If I remove a negative from a positive 9, I'm actually left with a negative 9. Because a negative times a negative is a positive. The reason why I did this is because a squared minus 9 is what's called a difference of squares. And what we're going to do is we're going to do some complicated versions of the difference of squares so you know when to recognize them. Okay? Here we go. Moving to the right. These are all examples of what? We're going to write examples of the difference of squares. And you can write this in your journal with nice and neat handwriting, unlike mine. Now, if you Google this, you probably see a squared minus b squared equals a plus b and a minus b. All right? Or you might see x squared minus y squared equals x plus y and x minus y. But that doesn't tell the whole story. The whole story is you're looking for perfect squares. So let's do a more complicated one. How about this? How about x squared minus 81? What is the square root of x squared? X. We got an x and an x. What's the square root of 81? 9. So we're going to plus 9. Now this one's not very complicated. Let's do a more complicated one. Here we go. What if I said 25a squared minus 49b squared? A little bit tougher. 5a up front, good. 7b in the back. And put a plus and a minus. There we go. You guys are getting it. You're looking for perfect squares, right? What's the square root of 25? 5. What's the square root of 49? 7. All right? Now, here we go. See if you guys can figure this one out. 169. X to the 10. Y to the 6. Minus 144. A to the 8. B to the... See if you guys can figure that out. If you're watching this video, I'm sorry. All right, but now would be a good time to pause it and see if you can do it on your own before I reveal the answer in just a few moments. All right, here we go. If you're watching this, you're getting ready to see the answer. Hopefully you tried it on your own. What am I going to lead out? I think I might need a little bit bigger parentheses here, so I'm going to erase that. What am I going to lead out with? 13. Then what? X to the 5th is right. Y to the 3rd. I could put plus or a what? Plus or a minus. So let's put a plus. What am I going to put here? 12 is right. A to the 4th is correct. B to the 6th. That is correct. Because what is the square root of 169? 13. What's the square root of x to the 10th? X to the 5th. And the square root of y to the 6th is y to the 3rd. And we just apply that same principle over to this one right here. Now, that's halfway done. Now I got to do the other version, right? That's going to be still 13, x to the 5th, y to the 3rd. But now I got to put a minus 12, a to the 4th, b to the 6th. All right? So that's complicated, but it's really not that bad. By the way, if you saw this on an SAT or ACT test, do you think it's part of the calculator or non-calculator portion? Non-calculator portion, correct? Now, we did all of this work so that we could take this information and go back and go, hey, I know how to factor this guy. This is easy. So in the numerator, right here, I've got a negative, and what does, let me scroll down a little bit, what does a squared minus 9 actually factor to? This guy. A. Good. Perfect. But in order for that to get factored, we had to actually do what first? We had to factor out this pesky little negative in order for it to work. So whenever you see a 9 minus an a squared, or 9 minus a b squared, or whatever it is, what do you have to factor out first? The negative. Very important. All right, I'm going to highlight that in blue. So we know this right here eventually factored to this right here. Now we'll do the easy one. This one right here. This is easy. Whoa. Down. Here we go. I got an A right here. I got an A right here. I'm looking for two numbers that add up to a 5, but multiply together to equal 2 and a. Put plus 2 and put plus 3. And that is the bottom, completely factored. Two numbers that add up to the middle and multiply together to equal the last. We've done that before. Now, this says division, right? So we got to be careful here. So I'm going to highlight this one in this wonderful magenta color. I'm going to highlight this one in this ugly green color. Now, this is divide, so we actually have to multiply the next part by the reciprocal. So watch what I'm going to do. I'm going to put the green up here and the purple right down there. Okay? Now, everybody, in the purple up here, we actually have to factor out a 2, because a 2 is in a 2a, and 2 is definitely in a 6. So 2 times what is 2a? 2 times minus, if I factor out a 2 here, what am I left with? 3. So right now put 2 parentheses a minus 3. And what am I allowed to factor out of a 5a and a 10? I'm allowed to factor out a 5. So right here, I'm going to factor, by the way, here's why we're allowed to do it, in case you're wondering. That's a 5 times an a. This is a 2 times a 5. What do they both have in common? They have a 5 in common. What's left in the middle? Yeah, an a and a plus 2. And how do you check it? You use the distributive property to check it. Everybody, we are almost done with this entire problem. Right now, I simply want you to look at it carefully. You see an a plus 2 I can cancel out? Ooh, let's cancel that. Right now, make it leave. That a plus 2 cancels out that a plus 2. Ooh, a minus 3. That cancels that out right there, and that cancels that out there. A plus. Those cancel. Wait. What's a 1? Oh my God. What do we only have? A negative, a 5, and a 2. So your final answer is negative 5 times. That's your final answer. All right, the last problem we're doing today on this video is problem number 14. Hopefully, we will have enough time to complete. Right now, the most difficult part right now is this part right in here. So this is called a sum of 2 cubes. The reason why they call it a sum of 2 cubes is because that's a cube and that's a cube, and you're adding them together. Hence the name sum of 2 cubes. So here's a pattern, everybody, for the sum of 2 cubes. A sum of 2 cubes can always be factored as a plus b in parentheses times an a squared minus an a times a b plus a b squared. So this is a special factoring that you need to put into your journal. You might run into something called the difference of 2 cubes. So here is the pattern for the difference of 2 cubes if you happen to run into one of these guys. Very similar to the pattern of the sums, just a little different. Okay. So this is the pattern for the difference of 2 cubes. This is the pattern for the sum of 2 cubes. So right now, we are going to follow this pattern. So, right right now, I'm just letting you know our A value is equal to x, and our B value is equal to 2 in this particular pattern. So what am I going to start out with? I'm going to start out with an x plus 2. And then I'm going to have an x squared minus a 2x plus a 2 squared. But 2 squared is 4. So right now, in blue, the sum of these two cubes equals this right here. So I'll highlight this in blue so you know this is completely 100% factor. Now I'm going to highlight this guy in red. Alright? I'm going to highlight this guy in green. And I'm going to highlight this guy in this beautiful magenta. Alright, the next thing we're going to do is we're going to factor out an x out of this guy and a factor out an x out of this guy. So right here in the denominator, I'm going to have an x, I'm going to have an open parentheses, and I'm going to put an x minus 2. Because x times x is x squared, and x times a negative 2 is a negative 2x. So now I have the red 100% completely factored. Now, if we're dividing it by this rational expression, we have to multiply it by its reciprocal. So right now, what I need you to do is I need you to put the purple on top, right here. And we need to put the green on the bottom, right here. Can you guys see how these are? This is going to be the reciprocal. So instead of dividing, I'm multiplying by the reciprocal. Now, this one right here in purple can be factored if you know what two numbers add up to 4 and what two numbers multiply to 4. I know, it's very difficult. We'll call it x plus 2 times x plus 2. Because 2 plus 2 is 4, and 2 times 2 is 4. So right here in the purple area, right here, I'm going to put in parentheses, x plus 2 and x plus 2. X plus 2 in parentheses cubed means I'm doing this expression not once, not twice, but 3 times. So that means this one is going to look like this. And x plus 2 times an x plus 2 times an x plus 2. I know, crazy. That's being done to the power of 3, so that's what it means. So now we need to search for things that we can cancel out. So I'm going to change everything to red and make this paper bleed. I've got an x plus 2 and an x plus 2. Got an x plus 2 and an x plus 2. Ooh. X plus 2. X plus 2. That's it. I can't cancel anything else. So my final answer to this problem in the numerator is x squared minus 2x plus 4. Now, if you're wondering why we can't factor it, because there's no two real numbers in the world that add up to a negative 2, but somehow magically multiply to a positive 4. We can't find those. There's no factors there. There are some imaginary numbers, but we'll worry about that later. Now, you have two possible answer choices. You could put x parentheses x minus 2, but if you wanted to, you could also leave it as x squared minus 2x. So either one of those answers would suffice, which means it's good enough. Okay? So you can leave it as x parentheses x minus 2. If you want, I would still count that correct. All right? So this right here would probably be an answer you would see on a multiple choice test. You have to know how to factor. You have to know how to cancel out factors in the numerator that are the exact same factors in the denominator to simplify these rational expressions. Have a fabulous day. Focus on.